In this video, we will be discussing degree and radians and how to evaluate and convert from one to another. So a degree is just a unit of angular measure. So a degree is just a unit of angular measure. When you discuss lengths, widths, heights, weight, that's all different units of measure. A degree is just a unit of an angular measure, and there actually is more than one angular measure. So when you talk about degrees, like you talk about 20 degrees or you talk about 50 degrees, it is just an angular measure of one object going to another object. So like this is where you would have 50 degrees, or you would have 20 degrees, 180 degrees, 360 degrees. It is just measuring the angle from one object to another object. A radian, however, it is also an angular measure, but it is very, very specific. 1 radian actually comes using the word radius. That's why you get radian. And if you take the radius from the center of a circle to the edge, and you were to take that length, and you were to wrap that length around the circle, the distance of that one length would be considered 1 radian. So if you take the radius and you were to measure it around, it would create 1, 2, 3 radians. So for example, if you had a circle sort of, and you had a radius of, let's say, 3 inches, and then you were to take a string that is 3 inches long, and you were to wrap that string as far as 3 inches would go, this would be roughly 3 inches. That would be considered 1 radian. If you were to wrap the 3 inches again, you would get 2 radians, and wrap it again, you would get 3 radians, and so forth. So a radian, it's a unit of an angle just like a degree is, but it is very specific to the side. Oh no. Yeah. Anyways, so if a circle is small and you only had like 1.5 inches as a radius, then you're only wrapping 1.5 inches around. If you had 3 inches, it's going further, but because the circle is bigger, the distance around is going to create the exact same place of that angle. So the angle itself is going to be the same. It is going to be 1 radian. If the circle is bigger, the radius is bigger, which means it has to go around a bigger circle of the circumference. But it's still going to give you the same measure of the angle from the center. There is a very basic conversion between the two. There are pi radians in 180 degrees. Because if you were to take a circle, which is pretty cool, if you took a circle and you were to, whatever this is, like let's just say this is just 1 inch, and you were to wrap 1 inch around, then you were to wrap 2 inches around, then you were to wrap 3 inches around, if you were to go straight across, that created a diameter, it actually represents 3.14 radians. What's that look like? It's actually pi. And that's actually where they get the number pi from. That if you were to take a 1 inch, or if you took 2 inches or 3 inches, because then it's just a bigger circle, and you were to wrap that distance around, and then wrap it again around, then wrap it again around, it would wrap about right here, and then there would be 0.14 inches left around, which for the diameter. And so that is why pi in 180 degrees is that conversion factor, that proportion. So here we could practice how many radians are in 60 degrees. So if our conversion factor is pi over 180, then 60 degrees would go on bottom because it needs to be where the degree is. So if 180 degrees on bottom, 60 degrees on bottom, and you're trying to find r, so you would cross multiply. 60 times pi equals 180 times x. So to solve for x, you would divide. Now, here's the deal. Do not put pi in the calculator. You're only wanting to reduce the fraction. So 60 over 180 is just 1/3, or 1/3 pi, or pi over 3, which is the exact same thing. So again, how many radians are in 300 degrees? So the conversion factor is pi over 180 equals x over 300. Again, 300 and 180 degrees need to both be on bottom. When you cross multiply, you'll get 300 pi equals 180x. So to solve for x, you're going to divide by 180. Do not put pi in the calculator, but you can reduce 380, which you can divide by 10, and then you could divide by 6. So you would get 5 pi over 6 if you were to reduce that. Now in this case, you're going the other way. So again, you would use pi over 180, but in this case, pi over 3 needs to go on top because pi's on top. If you have radians on top, then radians needs on top, and you're trying to find the degree. So you would have pi times x equals 180 times pi over 3. Now, here's something that's really cool. Anytime you're doing the conversion, the pi's cancel because pi on the left and pi on the right will divide out, leaving you with 180 times 1/3, which is just 60 degrees, which is why pi over 3 and 60, pi over 3 and 60. That's why it happens. Same thing with 2/5. So if we have pi over 180 equals 2 pi over 5, and x, when you cross multiply, x times pi equals 180 times 2 pi over 5. Again, the pi's are going to cancel because when you divide by pi and divide by pi, they will divide out. So you'll be left with 180 times 2/5, which will give you 72 degrees. Please do not forget the degree symbol for degrees, and the radians will normally have pi. It will not necessarily have to have pi, but many times it will. So when you're doing conversion, make sure you do keep pi in your answer. So to practice again, I want you to pause the video, attempt to do these problems, and then resume to see the answers. Okay, so you put 400 here because it's with the degree. So that should get you 20 pi over 9. This should give you negative pi over 9 because 2 over 18 is 1/9. This, the 5 pi over 4, needs to be on top. The pi's will cancel. Leaving you 225. Please don't forget the degree symbol. And we actually already know this one because I just realized this was negative pi over 9 here, which means this answer must have been negative 20 degrees. But just in case, to show you, negative pi over 9 over x. So x times pi equals negative 180 times pi over 9. The pi's cancel, and 180 divided by 9 is going to give you negative 20 degrees. And again, do not forget the degree symbol.